Hello guys, welcome to In 5 Minutes. In this presentation we are going to see the unused states in a counter or the bushing technique required in a sequential counter. Now we will check here whether the bushing technique is required or not. We'll check out the general design what we use to design the sequential counter. We'll design the counter with that way, and after that we will check the conditions for the unused states for which we put the don't care conditions. So the question is, examine the action of the counter for unused states, and the states here given in the counters are state 0, 1, 3, 4 and 6, and the counter is moving in such a way. Now here, to find out the number of unused states, first of all we need to take the number of states. So maximum number of state n is equal to 6 here, and we all know that n should be less than or equal to 2 raised to power m, where m is the number of flip-flops. So here m is the number of flip-flops required, the simple formula. And if we put n is equal to 6 here, so 6 should be less than or equal to 2 raised to m. So it is clear that the value of m is equal to 3. And if the value of m is equal to 3, so there will be 2 raised to n states, that is nothing but total number of states are 8, ranging from 0 to 7, that is nothing but 0 0 0 to 1 1 1. And we'll see carefully, the state number 2, 5 and 7 are missing, hence state number 2, 5 and 7 are unused states here. Okay, so we need to check the action for these states 2, 5 and 7. So proceeding to that, here what we require, let us build up the truth table, which will be consisting of the present states, corresponding next states and the flip-flop inputs. Okay, now to design this counter particularly, I am going to have T flip-flops. So there will be 3 flip-flops, TC, TB and TA. Okay, so what my present states are here, it is QC, QB, QA. Next states are Q of C plus 1, Q of B plus 1 and Q of A plus 1. That is going to be the next state, and the flip-flop inputs are TC, TB and TA. Toggle flip-flop I am going to use here. So present state, that is nothing but the conditions for all the states we have starting from 0 0 0 to 1 1 1. So let me complete the diagram for you. Okay, out of which the state number 2, that is nothing but 0 1 0, state number 5 1 0 1 and state number 7 are the unused states. So I'm highlighting these because I have to check the action of the counter for these states. So corresponding next states I will obtain from the state diagram. So here is my state diagram. Okay, following through the state diagram, what next states I am getting here, for 0 the next state is 1, so I'll get here 0 0 1. For 1 it is 3, same way. For 2 it is unused state, so I'll put a don't care mark here, so this will be don't care. For 5 also I will put a don't care, 7 is also don't care. For 3 the next state is 4, for 4 it is 6, for 6 it is returning to the 0th state and the cycle is complete. Now while filling up the TC, TB, TA, these are filled with the help of the excitation table that you all know, and the excitation table for T flip-flop is nothing but same as that of the XOR logic. XOR logic we have to put between the present state and next state. So writing the equation for TC, I need to put an XOR logic between QC and QC plus 1. So I'll get here 0 0, since both the terms are 0 XOR with 0, 0 XOR with 0. Likewise for these don't cares, I have to continue with the don't cares, so I'll put don't care marks here once again, and I'll complete the rest of the table. For TB it is 0 1 1 1 and 1. For TA 1 0 1 0 and finally it is 0 XOR with 0, that is nothing but 0. Now solving K-maps for all these 3. So let us try to solve the K-maps for these 3.